Okay, guys, let's review for our quiz over word problems and literal equations. Okay, so remember, it is important to establish your formula for each specific situation and then create an expression for each component using the same variable. The variable we use is the part of the situation we know the least about, and then we will substitute our expressions into the formula to create the equation. So it says Crystal is 12 years less than twice as old as Lori. Grant is 18 years more than half as old as Lori. The sum of their age is 83. So we have Crystal, her age plus the age of Lori plus the age of Grant is equal to 83. So the word sum told me how to write my formula. So we know the least about Lori. Crystal is being compared to Lori and Grant is being compared to Lori. So let's let Lori's age be X. Crystal is 12 years less than. Less than is a flip-flop, so we're going to flip the minus 12 to the back instead of at the front of the phrase. And then twice Lori will be 2 times X. So we flipped that around. Grant is 18 years more than half as old as Lori. So again, another flip-flop. So we're going to put plus 18, and then half Lori is 1/2 times X. Now we can substitute in our expressions into our equation. So we have Crystal's age plus Lori's age plus Grant's age is equal to 83. We are going to combine our x's and our constants. So we have 3.5x, which I will convert to improper, minus 12 plus 18 is going to be plus 6 equals 83. We are going to subtract 6 from both sides, and I'm going to convert 3.5. 2 times 3 plus 1 is 7 over 2 times x equals 77 when I subtract 6. We are going to undo times by dividing by 7/2, which is really multiplying by the reciprocal of 2 over 7. So our 2's cancels, our 7's cancel, and x is equal to 7 divides into 77 11 times, and then 11 times 2 is 22. So Lori is 22. Crystal is 2 times 22 minus 12. So that's 44. And then we subtract 12. And this gives us 32. So Crystal is 32. Grant is half of 22 plus 18. So half of 22 is 11 plus our 18 is 29. And if we were to add these 3 ages, we should get the sum of 83. So that is an age problem. The width of a rectangle is 8 more than half the length. The perimeter is 88. We're talking about a rectangle and its perimeter. So that is distance around. So we have 2 lengths plus 2 widths in our rectangle. So the formula is 2 times the length. Please put length in parentheses. It will help ensure you don't make a careless mistake. And plus 2 times the width equals our perimeter of 88. So the width of a rectangle is 8 more than half the length. We know nothing about the length, so let's let x be length. Width is 8 more than, so we have a flip-flop, so we're going to put plus 8 at the end, and the 1/2 times our length at the beginning. Now, this is why it's super important to have a formula. Now, use it. Don't just write it to be writing it. Use it. Our formula says we have 2 lengths. Well, what is length? It's x plus 2 times. So width, what is our width? 1/2 x plus 8. Those need to be in parentheses because we will be distributing. So let's distribute the 2 And this 2 times 1/2 x is 1x plus 16. 2 times 8 is 16. We're going to combine our like terms, and we have 3x plus 16 is equal to 88. We're going to subtract 16 from both sides, and we get 3x is equal to 72. We're going to divide each side by 3, and x, which is our length, 3 goes into 72. It goes 2 times, that's 6. We subtract, and 3 into 12 is 4. So x, our length, is 24. The width is 1/2 of 24 plus 8. Half of 24 is 12. 12 plus 8 does give us 20. So our width is 20 and our length is 24. And if we were to add those four numbers, we would get 88. So that is a perimeter problem. Josie wants to earn at least a 92 average in algebra. So far, her test scores are 94, 88, 92, and 90. What is the least score she needs to make on her next test to meet her goal? So the formula for average is you take all your values. So we have 1, 2, 3, 4, 1, 2, 3, 4, plus we're going to have a fifth test. You divide the sum by how many numbers were in your set. So that is going to be 5. Whoops. And we want this average, we want our average to equal a 92. That's her goal. Now let's substitute in our n sub 1. Our first number in our set is a 94 plus 88 plus 92 plus 90 plus, and I'm just going to use x for our next test that Josie's going to have. So please make sure you are neat and careful when you are working in algebra. And now we are going to combine our like terms. So I'm using a calculator. 94 plus 88 plus 92 plus 90 equals 364. So I just combine like terms. Please don't forget to bring down the plus x. Divided by 5 equals 92. Now we're solving for x, the grade she needs to make on her next test. But before we can get to x, we have to undo division and then undo 364. So we are going to multiply both sides by 5, and that gets rid of the divide 5. That's the point. I'm going to go ahead and bring over what is left on the left side, and then 92 times 5 is 460. Now we're going to subtract out 364, and x, the grade that she needs to make on her next test, is a 96. So if she makes a 96, she will have an average of at least a 92. Okay, the last type of word problem, I believe. Yes. There are 3 consecutive even integers with a sum of 1200. Consecutive means one after the other. So we're going to have a first number, and sum tells me what we're going to do. We're going to add these together, and a second number plus a third number equals 1200. So our first number is always going to be x. Well, let's talk about consecutive even integers. So let's just write an example like 4, 6, and 8 would be 3 consecutive integers. So if x stands for 4, what are we going to do to x to get to 6? Well, we're going to say x plus 2. And then to represent the third number, what are we going to add to x to get to 8? We're going to add 4. Now we're going to combine, or actually substitute in our expressions, and we have x plus 2 plus x plus 4 is equal to 1200. I'm going to combine like terms, and we have 3x plus 6 is equal to 1200. We're going to subtract 6 from both sides, and we get 3 times x is equal to 1,100. Oh, it's going to be 1,194. We're going to divide each side by 3, and we get x is equal to 398. So our first number is 398, and then 398 plus 2 is 400, and then when we add 4 to the x, we're going to get 402. Okay, now let's talk about literal equations, which just means we have many variables in an equation. We're going to manipulate it in order to isolate the variable that they tell us to solve for. So this is just rearranging formulas. So in this case, p is being squared, then it's being multiplied, and then it is being subtracted, then it's being divided, and then lastly, it's being added. Okay, so we're going to work backward. We're going to undo addition by subtraction. So we're going to subtract d from both sides. Notice that the d comes after the q that is already there. That's very important. It comes at the end. Now we're going to undo division by multiplication. We're going to multiply both sides times c, and notice you need parentheses because we have the difference over here. If we have subtract or add and we're going to multiply, you have to have parentheses. So now we have 2 times p squared minus k equals c times capital Q minus d. Now we're going to undo subtract by addition. So we're going to add k, and again, we're going to add it at the end. And now we have 2p squared is equal to c times q minus d, close parentheses, plus k. Now we're going to undo multiplication by division. We're going to divide by 2 the entire expression. And we have p squared is equal to c times q minus d plus k, all divided by 2. And then lastly, we're going to undo squaring by the square root. So I'm going to take the square root plus or minus of both sides. So p is equal to plus or minus the square root of c times q minus d plus k all over 2. In this example, we are solving for c. So this time we have c in the denominator. Typically, we don't mess with the variable we're isolating, but we will in this case. But before we get to any part of this term, we need to get rid of this term. So we are going to subtract d from both sides. Now we need to get c out of the denominator, so the only thing we can do is multiply both sides by c. Again, this is one of those few times where the variable you're solving for is moved. Now, again, we're solving for c. It's over on the right side now. It says c times the difference of q and d. So all we have to do is undo multiplication by dividing. And I no longer need parentheses because this long division bar serves that purpose. So these cancel, and now I have c is equal to 2 times p squared minus k all over q minus d. Okay, let's solve for h. So we have 2 terms. We're trying to solve for h, so we need to move this term. Go ahead and deal with that first. We have d times h minus g is equal to a minus w. Again, the minus w comes after the a. Don't forget that. Now, we need to get to this h, but first we need to get rid of the d times. So I don't want to distribute. So I'm just simply going to divide both sides by D. And when I do that, I no longer have parentheses. It took care of the parentheses. And now we just have to get rid of the minus G by adding G to both sides. And again, it's going to come at the end of what is already there. And age is isolated. I hope this helps.